Hey robot makers, are you an evil genius? Do you want to meet the person behind this book, Simon Monk? Then keep watching. So we've got a really special guest with us today. I have Simon Monk just waiting in the background. So Simon has got a degree in cybernetics, which I'm really interested to know a bit more about, and a PhD in software engineering as well. So he's been an electronics hobbyist since his early teens, and in about 2012 divided his work between writing books and designing products for his business that he started with his wife, MonkMakes, which manufactures hobby electronic kits and boards. So without further ado, we'll meet our new guest, meet the maker, Simon Monk. Hi Simon, how are you doing?
Hi Kevin, I'm very well, thank you. Nice
Great
to see
stuff.
you.
Thank you for joining me. So this channel is all about robotics and hobbyist electronics and so on. So really pleased, I think our interests really do align on this. So I'll jump into the first question I've got for you, which is when did you first get started in electronics and robotics?
Well, electronics as a schoolboy, really,
Yeah.
early, well, as a teenager, I used to go to the local library and get out, pore over the issues of practical electronics and practical wireless, and look for sort of strip board projects in there that I could make.
Yeah.
And without really understanding anything about how any of it works, it's very much follow this recipe. You'll need to
Yeah.
go and buy these components from your local electronic component shop.
Yep.
I grew up in Wolverhampton, and actually we had three electronic component shops. All three of them independent actually.
Yeah.
So I didn't, and I think later on there was a Tandy Radio Shack type turned up, that was making things from not even from kits, just going to the electronics shop, buying the components, which were primarily selling spare components for people, for mending radios and televisions and things like that, and then putting them together. Sometimes they worked, sometimes they didn't work. They might have worked after a while, and some of them didn't work ever. But I enjoyed doing it, and learnt to love the smell of solder fumes, which is sort of something that I think if you have worked on electronics, you do actually quite enjoy soldering. I don't know if you find that as well. It's just quite a
Absolutely.
pleasant activity, isn't it?
Yeah.
It's sort of satisfying the way you're sort of melting metal with a little instrument. It's good.
Yeah, and then it sort of solidifies, and then it's a real join, then, isn't it? And you've committed,
Yeah,
committed to the
exactly.
circuit.
Yeah.
Yeah. I mean, I've got a similar kind of background myself in that when I was very little, my dad worked in electronics. He was a TV repair engineer for radio
Okay.
rentals and Rumbelows, I think, before that as well. So
Right.
he'd
Yeah.
had a job with electronics, so that he always had like other people's TVs as a sort of, people always say, can you repair this, can you repair that? There was always stuff in his study, and it became kind of
Right.
like a mad scientist lab. There was all kinds of oscilloscopes and TVs half, with the back off and all the sort of scary electronics poking out, and that smell of solder as well. So he used to make little things for us. I remember one of the first one was like a little traffic light. He had like a 555 timer chip and it would go sort of red, amber, green and back again. And I found this fascinating because, this thing sort of came to life with real lights and things.
I remember a project very like that in something like Practical Wireless. I think
Yes.
probably a 555 timer, and then a 4017 decade counter, and then an LED, and then you can sort of ore together some of the outputs from this decade counter
Yeah.
to get the right periods for the different LEDs to make
Yeah.
your red, amber, green. I'm sure I remember something like that back in Practical Wireless 1979 or something like
Yeah.
that. But yeah, it was fun making little projects like that.
Yeah.
It was really good.
We used to go to those sort of radio fairs, radio ham fairs.
Oh yeah, great for second-hand components.
Absolutely.
And,
They had
surplus
all
components and things like that. Yeah.
all the World War II sort of surplus, supplies and,
Yeah.
they'd have like a Lancaster bomber radio set or something like that. And yeah, so I remember trawling through tents and
I went to one of those a few years ago actually, and I picked up some old Bakelite ammeters. And
Yeah.
I still haven't found a use for them, but they're just so nice. I just couldn't resist buying them. But
that's right.
I
There's
built
an
them into
aesthetic there,
something at
isn't
some
there?
point. They are,
Yeah.
yeah.
That's it. And like you mentioned about Tandy, Radio Shack, but in the UK, Tandy, I think was the name of the owner, wasn't it? Radio Shack. His second name was
Oh,
Tandy.
really? I didn't know that.
Yeah,
Yeah.
so there's lots of Tandys in the UK before they
Yeah.
went bust. And every Christmas I'd get the catalogue and I'd be peering through thinking, what is it I want to have from this kit? And they would
Yeah.
sometimes have these like 100 in one or 150 in one electronics kits with all the components on a piece of cardboard.
With the
And
little springs.
that's it, little springs, yep, and you put the
Yeah.
wires in and they'd spring back. And yeah, I think I had a few magic smoke experiments with that where the thing would, I'd short something out and it wouldn't work. But yeah,
Yeah, I seem to remember you'd get through quite a lot of batteries on these things as
that's
well, wouldn't
right.
you?
They didn't really explain very
Accidentally
well.
shorting them out.
Yeah, they didn't really explain very well how the thing worked. You'd spent so long just putting like wire from A to B and B to C and then
Yeah,
hope after like thousands of hours of doing this that the thing would work. Yeah.
exactly. Yeah.
But yeah, it was good fun that. So
Yeah, yeah,
have
no,
you
they're
built
good.
have you built any robots yourself? Have you and if you have, what was your first robot?
Um, yeah, well, fairly late on, really coming to building robots. So most of the stuff that I used to make because really very keen on all of this stuff as a teenager, and then when I went to university. When I finished university, all the jobs that were out there were software. So I really spent the next 20 years working in software and then came back to electronics as a hobby. So one of the first sort of projects I made actually when I discovered Arduino, because I'd sort of looked at microcontrollers before, and you could get little boards, development kits for PIC and things like that,
Yep.
but they weren't at all accessible. They were quite, there's a big cost of getting into working out how to
Yeah.
use them and things. And Arduino just made that so simple. And at the time I was a Mac user, well, I still am a Mac user as well.
Yep.
And Arduino just worked on all platforms. It was a really nice, simple, integrated development environment. There was good material on it.
Yeah.
Really, when I sort of discovered Arduino and started playing with it, one of my first projects was to actually try and make a Roomba style vacuum cleaning robot. My approach to it was a bit crude in that I got a couple of really cheap electric screwdrivers from CPC actually, and they make quite good gear motors, quite high current but incredible torque because they're a screwdriver, so that's what they do. And then I got a little sort of car vac that I had in the garage that I kind of strapped to the top of it at an angle, and then made the sort of control electronics, made it some little H bridges to drive the motors and things. And yeah, so that's probably the only sort of robot I've really sort of properly made for myself, as it were.
Yeah.
We had at one point we had a few products that were robot related. So we had we sold a board called the Raspberry Robot board, which was a little motor controller board that also had a socket on it for the ultrasonic rangefinder and a few other bits and bobs to make it easy to attach things.
Yeah.
And we actually sold a little roving robot kit, which is just a little two-wheel robot with a caster on the front, and then again with a rangefinder and a battery pack and things. So I've sort of messed around with that kind of thing, and we sell kits that are sort of to do with servo motors and things
Yeah.
as well.
That's probably a good moment to talk about your website, actually. So I'll just go over to my keynote thing here. So if people haven't already checked out monkmakes.com, if you head over to www.monkmakes.com, and you can check out all the different products that are on there. And I had a look earlier, and I saw there's one that's like some robot eyes. I was quite fascinated by that.
Yeah, I'd forgotten about that one. Actually, that's for a product we have for the BBC Microbit,
Yeah.
which is it's just uses a couple of servo motors with a little adapter that allows you to attach a ping pong ball as an eyeball to it.
Fantastic.
And then so you can swivel the eyes independently if you want. But it makes you can make some nice little projects with that. So it's basically a laser cut chassis that you sort of bolt together.
Yeah.
And then there's holes in the right places to put a couple of servo motors on, and
Yeah.
designing products, which I actually enjoy very much as well, but it's a kind of a different process and a different way of doing things.
Yeah. So I said in your intro that you do split your time between sort of writing books and designing boards. So tell me about the books. I'm quite fascinated. That's how I first came to know about your work. Was I bought this
Right.
Evil Genius one. So A
Yeah.
great book, by the way.
Oh, thank you. That was actually the first book that I wrote for about electronics, and
Yeah.
I did it just when Arduino was becoming popular, and as I was learning Arduino, and
Yeah.
started off really just sort of documenting what I was doing, not really intending it to be anything that would be published. And
Yeah.
then I thought, after I'd got really kind of a sort of couple of chapters worth of
Yeah.
material, I sent it around a few publishers. Didn't hear it, mostly to the UK ones,
Yeah.
and threw in a couple of American ones as well, just for luck. And then one of the American ones came back and said, which was McGraw-Hill, who did the Evil Genius
Yeah.
series of books. There's a whole load of books in that series.
Yeah.
And they said, the editor there said, would you like to change around what you've done? Says it's an Arduino Evil Genius project, which was a great idea on his part.
Yeah.
And it was just when Arduino was becoming popular, so it actually did very well. And then on the back of that, I started writing a few more books. At that time, all about Arduino, the different aspects of it. And this was pre Raspberry Pi and Microbit, obviously.
Yeah.
And I found that I really enjoyed doing this. And then eventually it kind of migrated over to being a full-time job, and gave up the day job, as it were. Well, there's a different story there, but I won't go into that. I left the day job, shall we say. And it's the writing did very well for a while, but one of the things people were always asking is, where do we get the components for your projects that you describe in these books?
Yeah.
And it's a really difficult thing to do. You go onto CPC or Farnell or Mouser or DigiKey and search for a 1K resistor, and you will get like 1,000 results. And I'm not even exaggerating. You will get 1,000 results. So actually, well, which one of these do I need? But I just want to buy one. I don't want to buy 100.
Yeah.
So springing from that, really, we started making kits and components largely to go with the books in the first instance. And then it's sort of taken on a life of its own, really. And now I'm spending more time on the business than on writing books. So most of my writing is to do with doing follow-on editions for books that are still selling well enough to justify a follow-on edition in the publisher's eyes. So, yeah. But designing PCBs and things is a lot of fun. I love laying out a PCB, laying out the tracks. I don't like auto routers at all. I much prefer to do that bit by hand. It's a bit like, it's doing a puzzle, and the joy is trying to connect all the bits that need to be connected without any of the wires tracks crossing over, obviously, and minimizing the number of times you have to jump from the top layer of the board to the bottom of the layer of the board. It's good, and the tools for doing that are very, very accessible now as well. I used to use Eagle CAD for it all, but now I've switched over to using KiCad for new projects. And it's very, very nice piece of software, and it's starting to mature and be a lot more consistent in the user interface and how everything works. It takes a little bit of learning effort to get used to it, but once you do, then you find that you can put boards together quite quickly. And it's free. So getting boards made is, in China, in small quantities of prototypes, is very cost effective.
Very affordable,
if you don't mind waiting a few weeks. Sorry?
I've been approached by quite a few manufacturers of PCBs, sort of saying, will you, if you need anything for your projects, come to us and we'll help you out with that. My issue there is I haven't got enough skills yet in PCB designing. I could certainly design them by hand, but not through the software. I just haven't got enough experience doing that yet. So that's an area of stretch for me that I'm interested in looking at more.
I mean, I did do a book on EagleCAD, but that's very out of date now. It went to a couple of editions, but then the second edition also hit the time when Eagle got acquired by Autodesk and changed everything. So it kind of killed the book, really, which is a bit of a shame. But I'm contemplating a book on, I actually started some notes and started doing some work on a book on KiCad. Because, there are already books, but they tend to be, and there are a lot of good free resources and things, but often, I think, the trouble with free resources is they can be quite disjointed, so they can, get you started in a particular area. But if you want really a kind of consistent body that you can work through and use as a reference, then a book, you can't really beat a book, I
Yeah.
think. I certainly, if I'm learning anything new, I always go for a book. I
Yeah.
don't like training courses. I have done them in the past, but generally,
Yeah.
I think I'd rather spend 20 quid on a book and sit down and read it and
Yeah.
come back to it and look over certain bits and, do it in a self-paced way.
Yeah.
But I think different people learn in different ways, don't they? It's just
Yeah.
what suits me. But
Completely
I would
agree.
encourage you to have a play with KiCad. Really do.
Yeah.
Follow some of the videos and have a, just draw a few, go back to your traffic light project. See
Yes.
if you can knock that up. And because it's so nice when it's like a lot of these things, it's like blinking an LED means so much more than just displaying a message on a screen.
Yeah.
And it's the same with PCB design, actually drawing a PCB
Yeah.
and then pressing the button basically to order it and then having it land on your doormat a couple of weeks later and think, ooh, that's really cool. That looks quite nice. You get a buzz out of it. It's good.
Yeah, I mean, I did experiment with... I designed a circuit board in just like a CAD package. OmniGraffle, it's called for the Mac. It's a really
I
nice
love OmniGraffle.
Exactly.
I use that for a lot of my illustrations in my book, actually. You might have even noticed that. I don't know if you can tell.
I did.
You did wonder, yeah.
I did. I noticed that. Yeah, it's like the rounded rectangles and stuff and the shadows and things. I certainly recognise that. So yeah, I designed a circuit in that. It was for a greenhouse robot using an Arduino, an 80 mega 328P chip. And the idea would be that this would be solar powered and it would monitor the health of some plants. It would the resistivity of the soil and stuff like that. Yeah. And I designed a little PCB in OmniGraffle. I then printed it using a laser printer onto just regular paper. And then you put that onto your copper plate and then iron it on. And the idea is it transfers the toner onto the copper, and then you get some ferric acid and etch away anything that hasn't got that ink over the top. And the bit that I couldn't get to work right, and I even bought an iron just to do this, was the sort of transferring. I'd get these really patchy and not quite. So I've got loads of failed circuit boards, and I kind of gave up on that in the end.
I used to do a similar thing with the method I used was you used to get overhead projector sheets that you could print on from an inkjet printer. Yeah. So that you'd print it onto this transparent sheet, and then I made myself a UV light box. Just with a whole load of ultraviolet LEDs all wired together, and then. You could actually just do it with sunlight as well. I did try, but we live in Lancashire. It's not a reliable method. But it's using the UV light box. You basically expose this coated PCB that used to peel a protective film off, and then you I used to clamp it in a picture frame and then expose it, and then you'd have to put it through a developer first, and then you'd put it in the ferric chloride to etch it out. And like you say, it's quite difficult to get that right, because if it's underexposed, then you don't get enough of the copper left. If it's overexposed, it doesn't work either. Yeah. If you leave it you don't leave it in the copper long enough because you think it looks all right, but it isn't, and then you take it out and you think, no, that's not ready. And it's a very hit and miss process. So
exactly.
These days, the Chinese, we've used PCBWay and JLC PCB, and both for if you just want 5 PCBs or 10 PCBs made, and all of our stuff is surface mount as well, so we tend to get a stencil as well. Yeah. Even by the time you've included shipping, you might get your 10 PCBs for the cost of sort of of that sort of thing for a cost of, I don't know, $20 or $30 or something like that for 10. So $3 each is really not worth having the chemicals or anything, because they've gone off, or you've lost them, or they're not very nice chemicals anyway, to be perfectly honest. Or you get a drop of it on your sink or any clothes, you destroy it. Stainless steel is not stainless in the presence of ferric chloride, I can tell you that. So it's really good it's very easy just to get this stuff made. Yeah, and they have checks as well, don't they? Before you submit it, they have all kinds of root checking. Checking the components and
like the
Yeah,
proximity.
I mean, Kevin, I mean, I'm full of admiration for you designing this in OmniGraffle, but really, if you draw the schematic in KiCad and
Yeah.
then you make the default PCB from it, and then you drag your components about, and then you connect up, you get these little, uh, air wires that you need to connect together with actual copper, and
Yeah.
it'll tell you when it's all done right. So you draw your schematic and you do one check on it called electrical check, that electrical ERC, electrical, I don't know, I can't remember what the R stands for, but that will make sure that everything is connected together, and there aren't any loose connections that you've forgotten about or anything.
Yeah.
And then when you switch over to the PCB view of your project, you can do a design rule check, which will make sure that there's no tracks crossing over each other,
Yeah.
that there's no things too close to each other, that it's not going to actually work when you get to have the thing fabricated and things. And then, like you say, when you upload, you generate some files called Gerber files, which is the computer-aided manufacturing files, upload them to the PCB service, and then they do kind of a check, which will render what the PCB will look like as well for you, so you get kind of a bit of an idea of it. It's very easy. So we get the bare PCBs made in China, going to MonkMakes now, when we're actually making thousands of boards. We get the bare PCBs made, but then we actually have a machine for stenciling PCBs in panels, and then picking and placing components on from reels and putting them onto the boards, and then we put them into a reflow oven that does it. But I mean, that's typical of our board, in that it's one of our relay boards. So there's not very many components on it, so it's not particularly demanding of the pick and place machine. So we can get away with having a fairly budget end of the spectrum for these machines. But it's I'd encourage anybody who fancies having a go at making PCBs to give it a go. It's easier than you think.
And here's one that I did a couple of years ago before my soldering was any good. Paper Arduino. And there's a sort of rat's nest on the back, and you can see slightly scalded bits of. But the idea is, and it did work. That did actually work when it was all soldered up and everything. You put the chip in the holder there, little crystal and the ceramic bits and bobs. But yeah, they do work. I did a video recently on how to build your own Arduino. Basically, it's just an 18 mega chip.
No, it is. It's very straightforward. There's not an awful lot to those things. The full-blown Arduino Uno, the commercial one, is incredibly robustly engineered. It's and you can actually get away with an awful lot less if you're just making one yourself. You really don't need all the bells and whistles for it. And you're absolutely right. I remember looking at I wanted to build something that would connect to a computer in some way, and I found like a PIC thing. I think it was in Maplins, which is sadly now no longer with us, but a bit like CPC or RS Components. Yeah, and they were a bit like Tandy as well. You could go in there and buy. I think that's where I bought the book from, actually, the 30 Arduino projects for the Evil Genius. I think that was from Maplins. Oh, whenever I went into Maplins in Preston, I always used to put them to the front of the book part of the section. So maybe you picked up one of them.
I might well have done that one. Yes.
Guerrilla marketing.
Well, it clearly worked. Yeah, and that was one of the the thing that got me into the Arduino. I'd seen that and thought, right, finally there's something that has lots of great documentation and therefore can sort of take me to where I want to be, which was building robots with Arduinos. That's why I love these SMARS robots so much. Not got one to hand actually, but they are powered by an Arduino Uno with a little motor shield on top, and it makes it very easy to sort of put together a robot that actually works just with a 3D printer. And so one of the funny things I just wanted to share with people about sort of how we met was through a mutual friend, Joe Sant'Arcangelo. So we worked in a school together, me and Joe, about 15 or 16 years ago. And we sort of kept in touch ever since. And he's noticed that, I started this YouTube channel about robotics and so on. And he said, I've got a friend, I go to these Raspberry Pi jams with. And, you should get in touch with each other. And I'd already bought a few of your books at this point and didn't know that, you were the Simon Monk. That's what I sort of jokingly said. And you'd sent me this kit, the MonkMakes starter kit. And I was reading through the instructions, and I've read quite a few instruction manuals in my time, and I thought, blimey, this is really well written. And it was at that moment the light bulb went on. I was like, no, he's not the Simon Monk, is he? Let me just go and check. And I was like, yeah, that's the same one in the back. It's got the MonkMakes thing. I'm like, oh, why? That's why it's so well written.
Oh, thank you very much.
Yeah. So that was the second book I bought by yourself, which is the BBC Microbit one. So when the Microbit first came out, I was a little bit not unimpressed, but I thought, oh, there's a bit too much on there. They've made it a bit too easy. So there's so many components jammed in here, accelerometers and what else we've got on LEDs and buttons and so on. I'd kind of been a little bit dismissive of it. However, I'd since really come to like this. I bought the more recent version as well. It's got the speaker on and the microphone, and it can even do speech synthesis. It's crazy on board. So, the fact that you've built an entire ecosystem that's really easy to connect things up with these crocodile clips, I'm a big fan. I'm definitely a convert to that. So just quickly sort of highlighting how we plug these things together. Let me just got that wrong one on there actually. Apparently that's how
it.
you.
We had a big debate really about whether it was better to try and use the ring connectors and alligator clips, or to just make a socket that you just plug the microbit into.
Yeah.
And we sort of came down to the conclusion that the trouble with just plugging the microbit into a socket is that you're not really learning anything about the electronics.
That's right.
So the thing about an alligator clip is that if you're using a relay with it, you can kind of see the circuit. So if you've got a relay and a battery and a motor, you can see the wire linking them all up together, and so you start to get an appreciation of what's going on electronically as well as what's going on in the software. But I mean, as a tool for teaching programming, then the microbit is great because you get that wow factor of actually making LEDs light and things that you don't necessarily get with pure software on its own. So this is it's a really simple board that just nice to make a little slider.
I mean, that's one of the things I love about robotics. It's kind of the intersection of three different skill sets. It's the programming side, which can be just purely programming. You're not really thinking about anything else. It's pure logic. Then there's the electronic side, which is very hands-on, and you're able to sort of create things electronically and interface with the software. And then there's the physical, mechanical design of the robot, where you build out a chassis or some kind of mechanical arm or something. That was the area I was always worst at. So when 3D printers became affordable, I was like, this is the thing that's going to solve my problem, because I can design things in Fusion 360, and I used Blender before I got into Fusion 360 to sort of design things in 3D. That to me was the kind of missing part. And then the electronics part, I knew some fundamentals, but not the deep theory behind, how all this works. My dad's always saying, "Oh, you should read up on this properly and really understand the theory behind electronics rather than just trying things out." But I like to
it's cheaper.
Exactly. Yeah. So tell me about what are some of the greatest challenges you have when you're thinking about the electronics boards, or even when you're writing the book. What are some of the sort of challenges you come up against?
I think. Because my background, I spent so long in software that I don't really have any fears from the software point of view. I sort of find that side of it probably the easiest part. I think my electronics, you mentioned earlier, my first degree was cybernetics. It was actually cybernetics and computer science. It's like a joint honours, and the cybernetics had a reasonable amount of electronics. It was mostly electronics and control theory. So there was I did at least kind of get exposed to the theory, even though I didn't really use any of it for about 20 years until I've come back to design boards now, and also get involved in more hefty sort of textbook style electronic books that are purely about electronics. So there was a bit of a challenge for me to get back into the electronic side of things and revisit all the bits of sort of little bits of theory that you need. I mean, 90% of what you do in electronics is Ohm's law or the power law. And if you know those two, you pretty much got most of the design decisions covered. And an awful lot of the rest of it just comes from data sheets. You want to use a particular chip. You will find the recommended decoupling capacity you put across the power supply. You will find that the recommended resistor values and some simple calculations for other components that you need. So I always start with the data sheet, and it's kind of it's the path of least resistance, and it's the thing that's is going to work if it uses the data sheet. The data sheet for chips is pretty much almost like a legal document. If you do everything that it says in this data sheet, your circuit will work, and if it doesn't, it's our fault, not yours. So it's always it gives you that extra security as a way of designing. 3D design is something I've always found difficult. I've wrestled with it a couple of times. I've never really got to grips with, something like Fusion or whatever. Generally, I try and find somebody who's good at that stuff and ask them to do it for me. I just find it easier. It's what you have sort of room for so many skills in your head, and then they start falling out the other side. And 3D printing, never something I've needed to do, or 3D modeling, never something I've needed to do often enough that I can remember how on earth I do it next time I come to need to do it. So it's that's sort of where I'd love to see a book actually with something like Mechanical Engineering for Dummies that kind of covered things, more basic mechanical engineering stuff, all the way up to things like 3D printing and 3D modeling. I think that'd be quite an interesting book. I'd buy that book. That'd be quite good.
Yeah, that's one of the interviews I'd like to do in the future. I have asked if he is interested, and he is. Is the guy who invented the SMARS robot? He was a student, an engineering student, design student, and he'd sort of designed this in his spare time, quite quickly actually. I think he'd only done a few prototypes of it. I'll find one just so I can show you kind of what it looks like. So these small robots, they've got the rangefinder at the front. It's very modular, so you can, I'll just move that back. You can take these things off and slide them on, and they're all 3D printed parts. So getting distracted here. So the wheels, all 3D printed. And
even the tracks.
Even the tracks. What's really neat about this, if I just get that to zoom in, you can see that it uses filament as the pivot. Now, this is the kind of innovation that's really smart.
Yeah. What a great idea.
And it uses the N20 motors. They're a really small motor. Have plenty of torque on them, but they're very cheap. About £7 to buy each, something like that. Plenty of torque on them. And the original version was for an Arduino. So it's designed that you'd slot the Arduino in, but I sort of changed up the design a bit and have a Raspberry Pi Pico there, so I can use some MicroPython. And instead of the motor shield, I've just got a little board there that you can plug into the Pico. You could also do that with a microbit. I've made a microbit version, and this particular one has got a wireless charger underneath, so it's got like a contactless charger.
Clever.
So it's quite neat.
Yeah, very good.
Yeah, and then I shrunk that one down to do a really small version of that. So this is with a what's it called? A tiny 2040 from Pimeroni. So there's a tiny little Raspberry Pi compatible chip just sat in the back there, and it has a laser rangefinder on the front as well. These are really great. I didn't think you could have a laser for less than £100 or something. These things are like £1. They're very cheap. So it's just a little. Is it an L? Oh, I can't remember the name.
I can't remember part number for that.
No.
But yeah, they're a lot smaller than the ultrasonic rangefinders. And a lot more accurate.
Yeah.
Don't have quite as big a range, I don't think, do they? They can't go out quite as far. But it is incredible that you buy a little chip that's got a laser, infrared laser coming out of the front of it.
That's it. It's unbelievable.
But not in a dangerous or exciting way. It just tells you how far away things are.
That's
not going to blind anybody.
Yeah. And what I like about these SMARS robots is that, as well as being configurable, I'll just grab another one there. The modularity of it is really quite useful. So this one has on the back a line following module. I just had this apart before, that's why it's sort of half stuck out the top. So yeah, you can just plug that into the top of the Arduino, and then you can sense whether or not it's on a line, and you can make it follow a line around a track. So very simple to print this out and put the module that's just in there and add to it. So you can really build these things out. Add Bluetooth to them to make them controllable remotely from an app. So I've played around with that as well. And I was that obsessed with these, I started like a fan site, because there was lots of information sort of scattered around everywhere, but nothing in a central place. So I created smarsfan.com as my place to sort of put this. And then I thought, I like too many different types of robot, not just the SMARS robot. I'd first started building an in-move robot, and I'd sort of overstretched there by trying to build something that's physically too big that took a long time to print, and also my
Okay.
programming skills weren't really up to it at that point either. So I've
Yeah.
since learnt Python to a reasonable level anyway, so I could go back to that. But I've actually quite enjoyed the small robots, so that's my area of interest really. So back to yourself then. So when you go through designing your boards, do you have like a process, or is it more experimental? Do you think there's a need in the market for this type of board or sensor?
Yeah, quite often it comes out of conversations with sort of either our retailers or people who use our products, who just sort of say it'd be great if you had a board that did this, and it's in terms of what it should do and what it should look like and things. I do actually start with a blank page on my notebook and
Yeah,
a few bullet points. What are the features of this thing should have?
yeah,
And then a sketch of it to give an
yeah,
idea of what it should look like.
yeah,
And then having done that, I'll generally I'll make a small batch prototype like we were talking about before. So
yeah,
I'll design the schematic. I'll make get a small quantity of PCBs, hand pick and place the
yeah,
components on them, and then get them. Yeah, that's one of our sensor boards, and then put it on a send it out to a few people quite often
yeah,
to have a play with, see what they think, and then sort of if it's looks everybody like if people like it still and it still looks like it's going to be a reasonable product, then we'll do a first batch, and we always
yeah,
do quite a small first batch of maybe like 100
yeah,
or 200, and then if it sells well, then we order a big quantity of panels and make up lots of them,
yeah,
and see how it goes. So it's all sorts of different sources for sort of inspiration for where it actually we start off making something.
yeah,
Quite often, actually, for a lot of our more maker-oriented products rather than the microbit stuff, it's because I want a board that does this. So,
yeah,
it's the servo board is a typical case of that. It's connecting servos to something you built on breadboard is a pain in the neck.
yeah,
Loads of male jumper wires trying to fit into the sockets on the servo motors. I
yeah,
just wanted something that would really make it really easy to connect up
yeah,
half a dozen servo motors to control pins and to accept their power from something with a screw terminal block that I can put a battery pack onto.
yeah.
And so that would be the kind of motivation for that.
Yeah, and chances are, if you want it, somebody else wants it as well because they're having the exact same
Yeah.
kind of challenges that you're having.
Yes, you always hope that you're not the only person in the world who happens to want this particular
Yeah.
thing.
Now, one of the really
Sometimes they
nice
work,
things,
sometimes they don't.
one,
There's no way of predicting it. That's the bizarre thing about our products. You can make something you think that's just such a good idea, that's going to sell so well.
yeah,
We thought about this, and then you find that nobody really buys it, and you no idea why.
no idea why. Now, one of the things I really like on these boards is where you've got the MonkMakes logo. There's a little LED that lights up when you power the board. I
Yeah, I
like
was
that a
pleased with
lot.
that. It's a nice touch, isn't it?
That's really nice.
Yeah, little orange LED that
Yeah,
not too bright, that just looks like a sort of slightly deficient tungsten light bulb.
that's
Although
right.
kind of getting a bit dated, really, isn't it? Having a logo that's a light bulb.
I don't know. I quite like that. I like
Yeah,
the fact it tells you that there is power going through it and you've not wired it incorrectly.
that's true. Yes, it's a good first debugging
Yeah,
idea. Yeah.
yeah. That was another one that we were looking at earlier, which was the
Yeah,
connector.
this is our first sort of departure into having something for connecting, plugging a microbit into. But
Yeah,
really, we've done it to kind of open up extra pins
yeah,
on the microbit. I mean, there's lots of other similar products out there, but we tried. One of the things we wanted to do is carry through the ordinary ring connectors so that you can still
yeah,
see them,
yeah,
use them, because a lot of them don't. Most of them don't do
yeah,
that. Actually, they just you've now
yeah,
plugged your microbit into something. It's now an appliance, where we quite like the connecting things together thing.
yeah,
But it's really useful to have the I squared C
yeah,
connections of the microbit available, because you get a lot of nice little OLED displays and things that you can plug onto that I
yeah,
squared C interface just with
yeah,
some jumper wires, and people want to do that quite a lot.
yeah.
So we thought we'd make a nice, easy way of doing it.
Yeah, when you were talking earlier about data sheets,
Yeah.
I've looked through quite a few data sheets for various different boards, and one of them was about an I squared C. I was trying to understand how you get this thing to work. I was trying to get something to work in MicroPython where there wasn't a library that existed
Yeah.
already for this. So I was like, what do we need to do? What bits do we need to bang into that bus to make it sort of come to life? And yeah, I was reading through the data sheet, and like you said, it is like a legal document. It tells you precisely how this thing should work.
Yeah, but no nice easy example that you can
No,
just type in and do. No,
exactly,
that would be lovely, wouldn't it? It saves
wouldn't
so
it?
much time. You do get the sort of. I've done a few sort of implementations from scratch of talking to I squared C devices, and you do sort of. There is a sort of kind of pattern to it, in that people tend to use sort of registers. So you write things
Yeah,
into a register, and then that does something on the device, kind of thing.
yeah,
So you move away from the thinking about the sort of bit banging and what's actually the
yeah,
information being transferred, and think in terms of putting things in registers. And then
yeah,
again, from the software point of view, you want to try and encapsulate that in a library and
yeah,
save somebody else some pain if you possibly can.
yeah.
And
So
actually, it's amazing how often, I mean, there are so many really good libraries out there that you find that people have
yeah,
developed. Yeah, that's a 7 segment display, bit a retro
yeah.
display really for the microbit.
So I did a project
Um,
recently using one of these. Not sure if I've got it in the background. It's
yeah.
just over there. It was the time machine console from Back to the Future, and I had a
Oh,
whole
lovely.
bunch of these, and
Yeah.
that's where I was figuring out how to use shift registers so that I could put a digit in and then move it along, so I didn't have to have thousands of wires all hanging off the
Okay.
back. Yeah, so that was.
Yeah. Yeah,
But
I
yeah,
mean that one we use a serial interface to actually talk to the board, because
yeah,
the I squared C interface on the microbit is hidden away on the little pins in between the big rings.
yeah,
So and of course you need 2 pins. Whereas if you're actually just wanting to send data to a display,
yeah,
you can use the somewhat old-fashioned UART serial interface, so that
yeah,
you just effectively send messages, and you're really only tying up one of the data pins of the microbit.
yeah,
Um, so it's you've lost the electronics of how the display is being refreshed and all that kind of thing, but at
yeah,
least you know that you're sort of kind of communicating with the board, and you've got to
yeah,
supply the board with power and things. So you're getting something out of the connecting it up, I think,
yeah.
as well.
Yeah, and then most recently, the sort of new kid on the block, not too new now, but I suppose it's still not that old, is it? Is
Yeah,
the
I really like the Pico. The Pico is the best Arduino you can buy.
yes,
I think really.
for the money,
Um,
absolutely.
it's good value. I like the microcontroller is fantastic. I think I really like the job that the Raspberry Pi Foundation have done on the design for that. It's got
Yeah,
a lot of the things that you would want, and from a software, people come from big software, 2 cores. Oh, you can do 2 things at once. That saves a lot of the pain of having to watch for key presses and refresh a
yeah,
display, or monitor sensor values or something. You can at least do that
yeah,
without worrying about horrendously complicated state machines or trying to work out how to code it. You
yeah,
can make life a lot easier for yourself.
yeah,
And the programmable I/O stuff is incredible. So if you want to drive NeoPixels or something, you don't even need to do any actual tie up either of your cores. You can actually have that
yeah,
running on the pins to some extent.
yeah,
And the power supply is very well designed on that. So they use a type of power supply called a buck boost, so that
yeah,
that means you can supply it with lower than it needs, and it operates at 3.3 volts. So you can either
yeah,
supply it with lower than 3.3 and it boosts it to that voltage, or you can supply it with slightly more and it drops it back to that voltage.
yeah,
So it means for powering your Pico from batteries, it just makes it very easy. You can
yeah,
do it with a couple of AA cells, or you can do it with a lithium polymer battery, or
yeah,
so fairly wide range of voltages. So it's a very nice designed board. The only thing that I thought was insane was that the thing telling you what the pins do is on the underside, where you can't
yes.
see it
It's
once
on
you've
the wrong
stuck it into a
side.
piece of breadboard. So
Yeah,
one of our products that we're actually very pleased with, I can't quite see if that is one of our breadboards, but we've had breadboards made that
yeah,
have the pin names of the Pico
yeah,
actually on the breadboard, so that once you plugged your Pico into the breadboard, you can actually just look at the breadboard to see which pin you're connecting to what,
Yeah.
rather than have to try and cross-reference it to a diagram that it always goes wrong. You always get one out, or and counting down the number of pins. You shouldn't be counting things; they should have a label on them.
Yep.
So we tried to solve that problem with our breadboard for Pico product, and we're selling a lot of them actually, which is quite pleasing.
Yeah.
But yeah, I do like the Pico, and I've always been a big fan of Arduino. But the problem with the official Arduino boards has always been that they're much too expensive.
Yes.
They're very good quality, and I can see why they're expensive. But for a lot of makers and a lot of educational settings, they're just much too expensive. And something like the Pico, and although you can program the Pico in Python, and that's probably the best place to start when you're getting to learn about how to use it, and particularly if you've already done some Python or you've learned Python at school or something. But you can also program the Pico as an Arduino, which I think in C. I can't remember the name of the guy, but he's done an absolutely fantastic job of creating what's called an Arduino Core, which basically allows you to use other types of board within the Arduino integrated development environment as if they were a genuine Arduino.
Yeah.
And it's just very good, very, very... you get that extra bit of performance as well doing it in C rather than doing it in Python. I'm a big fan of the Pico. I think
me too. I mean, I think for me, one of the things that have made it really successful is that you've got that flash storage as well as the RAM. So it's a bit like having a disk, a hard disk on the microprocessor board, that you can have these, because Python programs are quite efficient size-wise, but they're not as small as, say, a C program. But if you one of the challenges that Camillo had with his Auto DIY robot, so this runs on an Arduino Nano inside. If you sort of pull its head open and have a look what's sort of running that, it's an Arduino Nano.
Yeah.
And the software he's written for this is so extensive that it runs out of memory and crashes if you have everything enabled. Now with MicroPython, you could write a really clever program that manages the memory so that it only loads things in when you need them and doesn't max out the RAM, because the script can be as long as you like. You can write a very large script in 16 megs of cache of flash memory. So
it's just the next generation of processor. The Arduino stuck with the Atmega chips, which are really sort of chips from the 1990s, I think, aren't they? I mean, they're quite dated. Tiny amounts of memory, which sometimes that's absolutely fine. That's all you need. But then, the modern generation are good. I think I'm actually quite... well, they're not Atmel anymore. They're Microchip, aren't they? They've been bought by Microchip, the Atmel company, the people who make the chips on the original Arduinos. But they have brought up to date some of their microcontrollers in a really nice way. The ATtiny... the ATtiny 1614 is sort of my favorite low power microcontroller at the moment, and the RP 2040 is my favorite sort of high power microcontroller, as I would class it. And one of the things that you don't get with a Pico, with the RP 2040 microcontroller on the Pico, is you don't get very much output current from your GPIO pins. So you're really supposed to, I think, keep it on, I don't know the exact figure, but a few milliamps. Whereas the ATtiny 1614s, you can draw sort of 40 milliamps for a few of the pins. This is the total budget of current as well. So they'll do much higher current. For example, the 7-segment display you showed up there before, if you're careful about the duty cycle and things, you can drive it directly from the microcontroller. So that microcontroller is one of these sort of new generation of microchip low cost microcontrollers that's absolutely fine for something like controlling a display or whatever.
Now, one of the things that drives me a little bit nuts, though, about the MicroPython environment, because I'm a very big fan of Python and MicroPython particularly, but it's very different depending which board you use. So if you have a microbit or you have a Pico, the same piece of code doesn't necessarily run on both of them, because one might use the machine.pin, machine.ua, and the other one might use board.something if it's like a circuit Python, or if it's the microbit. I think the the microbit make code website has full Python. So it's different again. So things like, getting the onboard LED to flash. I think Damien's tried to address this in a later version of
Yeah.
Python. He's trying to bring things together, but it's a little bit fragmented at the moment in trying to get everything
It's
to
this
work.
idea of having a hardware abstraction layer. So
Yeah,
yes, you have a sort of class that has all the stuff that's specific to the Pico, and you have a
yeah,
class that's all the stuff that's to do with the microbit. But
yeah,
then within those classes, when it comes to actually doing things with pins, or even whether the pin is a class,
yeah,
or how they're arranged in a hierarchy, is
yeah,
completely different. There's people that always seem to go their own way on this,
yeah,
rather than sort of kind of adopt a sort of standard approach to the hardware
yeah,
abstraction layer, which would make life easier when you're switching between boards.
yeah.
I must admit, you see it even with the microbit between using CircuitPython and using MicroPython.
Exactly. Yeah,
It looks quite different how you
yeah,
access the features of the board,
yeah,
which makes it difficult for the beginner because you'd expect
yeah,
to do things the same way. In
yeah,
many ways, the Arduino IDE provides, if you like, a very good hardware abstraction layer, because the stuff that you can do, you can program a Pico on the Arduino IDE,
yeah,
or a microbit on the Arduino IDE, and the way you deal with pins will be pretty much exactly the same.
yeah,
So it is a very good. I'm a big fan of the Arduino integrated development environment.
yeah,
It's really now the biggest strength of the platform. I think
yeah,
the Uno will always kind of be the standard Arduino board, and it's great from
yeah,
that point of view, and it's very robust and good board.
yeah,
But the power that you get from the integrated development environment, where you can attach everything from a microbit to
yeah,
a Raspberry Pi Pico to the Espressif ESP32
yeah,
based boards, which have got
yeah.
a bit like a Pico, but you've got Wi-Fi and Bluetooth as well,
Yes.
for a few quid.
Yeah,
Are quite, and you can do all of this stuff in exactly the same way on the Arduino IDE. So I
yeah,
think it's a very good unifying platform from that
yeah.
point of view.
It's funny you should mention that, the ESP chips, because whenever I do a video on the Raspberry Pi Pico and the benefits and still in the virtues of this, people say, yeah, but you could do that on an ESP32 or an
Yeah.
8266 chip. Why don't you do that instead? Because it has Wi-Fi as well. And it's like, well, they're a bit more expensive, for that extra bit of Wi-Fi. Do you really need that in your project? What if you just don't need that? So I quite like the purist approach with the Pico. It doesn't have anything it doesn't need, and if you need to add something like
Exactly.
that to it,
Yeah.
you can do.
Yeah, exactly. Well, I think with most projects, it's a case of, unfortunately, learning a bit about all of these different boards and getting some skill in all of them, then picking the
Yeah,
one that's right for your project, isn't it? So if you don't
yeah,
need Wi-Fi, there's no point in having a
exactly.
Wi-Fi board, really.
Yeah,
And I think, other little niggly things with some of the ESP-based boards is that when you upload a program onto them, you have to wait quite a long time. I seem to remember.
yeah,
Which isn't a big thing, but then if like me, you do a lot of small incremental
yes,
changes rather than bang a load of code in and then spend 3 years debugging it,
yep,
I find it's quite annoying if I have to wait. Whereas the Pico
yeah,
is very quick to upload. I'm not quite sure how they do that trick with the Arduino IDE, because
yeah,
I would assume it's just copying stuff into EEPROM, but
yeah,
for some reason they don't have to copy as much, or it works faster or something. But it definitely a lot
yeah.
better.
And that's one of the things I like about MicroPython is you can do that incremental changes very quickly. You can iterate through, your
Yeah.
development without having to sort of wait for the compiler to sort of create all the code. It just does what you need it to when you need it,
Yeah,
because it's
well, and you
interpreted.
can experiment from the command line, can't you?
Yes.
From the read event REPL, the read event
Yeah.
print loop that lets you just type in Python commands
Yeah.
with what it already knows about the program. It's just run, so you
Yeah.
can even look at variables and see what's going on a bit. It's a
Yeah.
great debugging environment
Yeah.
if you're finding things not working quite how they should do.
Yeah. And I think that, once you've learned one programming language, it's not too difficult to sort of transfer that skill to another one. It's more of a dialect thing, isn't it? I mean, I
I'd
know when I
agree. Yeah.
yeah, when I looked at Python originally, I was a bit confused by things like, why doesn't it have a select case statement? Why do you have to do if else, else if, all that kind of stuff? Why can't you just have like a case select statement? And funnily enough, the new version of Python 3.10, has exactly that. They call it pattern matching, I think.
Yeah, I don't like that structure.
No.
One of my pet hates. I really don't like switch and case statement type thing.
Yeah.
If, just use if.
Yeah, it lends itself to
Nothing
spaghetti
wrong
code,
with
doesn't it? Exactly. Yeah, yeah.
Yeah,
Having
I
that
think.
break
Well,
after.
it's mostly just laziness because I can never remember the syntax. But I'm quite happy with if. I'll stick with
Yeah,
that. Thanks very much.
that's it. So you were saying before about you were learning some programming language that you became very familiar with. So was that C, or what was the languages that you were learning back
I've
then?
sort of had 20 years in software before I really sort of came back to this. So
Yeah,
most of them really. I mean, I do very fond of anybody who's programmed in Smalltalk will rant on for hours about how wonderful Smalltalk is, and it
yeah,
is. It is the best programming language. I'm not going to take any argument from anybody unless they've actually programmed in Smalltalk on that one.
yeah,
It's incredibly productive, and people don't like it because it hasn't got source code files, and they think, "Where's the source code?" I mean, your system is there. You change it till it does what you want, and then you freeze it.
yeah,
And it strips out all the rubbish you don't need, and you're left with a functioning program that's really easy to maintain and properly object oriented. So
yeah.
I'll stop there because otherwise I'll just go on all night about small talk. But I think I started with actually Fortran 77, and
Wow.
then
Yeah.
C, and then Lisp, Common Lisp.
Lisp. Yeah.
Um, and then what after that? Well, then it was Smalltalk, and then I spent a lot of time doing Java Enterprise stuff,
Yeah.
and then ended up doing most of the stack. So I do know how to do sort of, JavaScript as opposed to Java. People often think they're the same language.
Yeah.
They're totally different languages.
Yeah.
And then embedded language, and then Python came to sort of when it started to become a thing for embedded
Yeah.
computing. I had a look at Python and did a book on that with using Python with the Raspberry Pi.
Yeah.
And then Ruby on Rails. Ruby is quite a nice language. If the world is not ready for Smalltalk yet, Ruby is not a bad alternative. And Ruby is quite an easy language to learn. It's a bit strange in that it often has multiple ways of doing exactly the same thing, which a lot of programmers hate. I just want, give me the best way of doing this. I don't want to know 3 other ways of doing it. I just want the best way. And Ruby is a little bit like that. You can do some sort of strange things with it, but it's actually a very powerful language, and its power comes from its being fairly purely object-oriented, which Python sadly isn't. But Python is a good one to start with.
This is what I learned when I was at university. JavaScript 1.2.
Oh, okay.
It's literally just been renamed from LiveScript. So,
okay,
that's how old this particular book is. But I've never really taken to JavaScript, to be honest.
It's a strange language. It's because it's what they call a prototyping language rather than a pure object-oriented language. So you make a thing and then you make a copy of the thing rather than defining the class of a thing and what that means in terms of everything about that class.
Yeah.
So it's unusual. It's actually a very powerful language, JavaScript, but it can make for incredibly unpleasant code, and the obsession with never waiting for a method for a function to return, always using callbacks and things, leads you to these long, horrible chains. And then they put sort of syntactic sugar into the language to try and make that more transparent. And I just think, surely the compiler should be handling that sort of stuff for me. Let me just express my ideas and have it function, please, compiler. I don't want to know about all this asynchronous stuff.
Yeah, and I was a fan of Java for a while when it was Sun Microsystems, when they owned it and developed it, and it was completely open source. It kind of took a dark turn, I think, when Oracle bought it and made it a bit more proprietary and more enterprise oriented. A lot of companies have spent a lot of money making Java based stuff, but
I spent a lot of time on Java Enterprise stuff, and the problem with Java is really that it's what you call over patterns. So if you want, you don't just do something. You first of all define an interface that describes what you want to do. It's a little bit about a gripe I have with C to some extent. Why do I need a header class and a C and all the compiler's going to do is whinge until I've made them agree with each other. And at least the Arduino has the good grace to sort of hide that from you, so you don't need to do that. But it's rather similar in Java. You end up with long, complicated patterns. Okay, they add flexibility, and I think also to some extent they keep Java programmers in work as well, if we're perfectly honest about it.
Yeah, and I think it's now been taken over, hasn't it, by Python as the world's most popular language. It was
It is,
JavaScript
yeah, I
and
believe
Java.
so. Yeah,
Yeah,
yeah. I mean, Python is a great integration language. It's great for tying together bits. So
yeah,
I've done a bit of sort of playing about with machine learning projects, really just for my own interest. It's something I felt I needed to understand,
yeah,
and that as a all of the machine learning stuff, is all wrapped in Python, so that you can, and actually done very nicely, so that you can kind of
yeah,
just to plug in different types of engine to make your inferences for you.
yeah,
So yeah, it's a good from that point of view. There's just some things in it that kind of make it look a little bit like a bedroom language, don't
yeah,
they? It's kind of it's not. This does not look like something designed by a computer scientist. Let's put it
yeah,
that way. But so what? It works.
yeah,
People take to it. People learn it quite quickly, and
yeah,
as the first language, I don't think there's much wrong with it at
yeah.
all.
And it's interesting that it's in some areas like data science, that is the language to learn. Have the
Yeah,
NumPy and pandas to, take things that you might be doing in Excel or in, I don't know,
yeah.
SQL databases and
Well,
then take
the
to another
Jupyter
level.
Notebook. Have you played with the
Yes,
Jupyter Notebook?
absolutely.
That's really nice, because you kind of weave your code in with
Yeah,
comment with story about what you're doing, and then you can
yeah,
sort of have all these little scripts, and you can just create a sort of workflow from them. So
yeah.
they're very productive environment. Very nice.
Absolutely.
Yeah.
I find sometimes when I'm experimenting or trying to shape something, I might go to a Jupyter notebook and try it out because I love the fact you can just rerun the steps just to the bit where
Yeah.
you're working on and then carry
Yeah.
on. It's fantastic. Like you say, very
Yeah.
productive, very and then
Yeah.
put your comments in between it, even like markdown comments. Yeah.
Yeah.
I really
Yeah.
do
No,
like
it's
that.
nice. Yeah.
Yeah, yeah. So back to my questions. Let's see what else we've got on here. So one of the questions that Ovi, who's our first guest on here, he said, where do you think the field of robotics will help improve our lives and the environment? So is there anywhere you think it hasn't touched yet where it might be a nascent
Uh,
market or?
well, I don't. I think domestic appliances have still got a long way to go. I got all excited when we've discovered that our washing machine actually had a Wi-Fi hardware in it. I thought,
Oh,
brilliant! I have like a Raspberry Pi in the house that controls a lot of the light switches and
yeah,
various other little projects I've got going on it. I thought, fantastic! I'll buy washing machine will be able to tell me when it's finished washing, or I'll be able to turn it on when electricity is cheap, or I'll be able to do all
yeah,
sorts of clever things. No, not a chance. It's kind of, it's all closed, proprietary, belongs to the manufacturer. They will sell you some rubbish software that won't do what you want anyway,
yeah,
and it's a waste of time. So I would love to see, it's kind of not quite robotics really, but I would love to see those kind of interfaces mandated to be standard. It's the sort of thing that the EU would do
yeah,
brilliantly,
yeah,
and just say, right, you're going to do this now.
yeah,
You, you can, you've got to, like the cookies policy and other things like that, or
yeah,
vacuum cleaners that don't use megawatts.
yeah,
It's like, everybody whinges about it, and then they do it, and they think, yeah, why didn't we do that years ago? That's a
yeah,
brilliant idea. So I think it would be nice to see some of that going in, and
yeah,
then I think in terms of sort of balancing sort of the national grid and things like that, or you can see so many opportunities when you start to
yeah,
allow sort of sensible use of electricity, so that as we rely more and more on renewables, we've got to be an awful lot smarter about that,
yeah,
because we don't have the sort of base load generation knocking about there. And if
yeah,
people's cars can contribute to that when they're not being used, as long as you have some kind of promise arrangement that is, I promise to give you 100 miles range in your car in the morning, but you
yeah,
can do what you like with the battery overnight or whatever.
yeah,
That's the smart grid stuff is going to have to come in.
yeah,
I think yes, that would be good. I mean, self-driving vehicles. I'm looking forward to that day. I
yeah,
don't particularly like driving, so actually having a mechanical chauffeur, brilliant idea. I'd love that. I think a lot of the machine learning stuff is very interesting. But Edge Impulse, I have to follow them what they're up to, because they've got some lovely little demos with a microbit where you can teach it things. And this is so you basically do all your training on high-powered computing somewhere, and then you
yeah,
download a tiny little model that just knows how something works. So
yeah,
room occupancy is a classic example of this, where you connect some sensors up to a processor, which could be a Pico or a microbit. It doesn't have to be a particularly high-powered thing. It has to be a bit more than an Arduino Uno. You're struggling with that. You really need the current generation of microcontrollers to do that, but not the not fantastically powerful machines by any means. And then you just having trained some data and put this model onto your device, it can then just look at sensors and work out, yep, I think there's somebody in the room, or no, I don't think there's anybody in the room, and turn the light on or off. Having been trained, having learnt how to do that from example data. And I think we'll see that in more and more things. And I think it's an exciting time. I think it's really interesting technology, that. And I think things like sort of smart speakers will get a lot smarter. So they're still pretty stupid, aren't they? And they don't really remember what you said to them. And it's like, so we're at the point where you're actually having a sensible conversation with them, not about philosophy or anything, but just about what you want your lights to do would be a big step forward, I think. And that will, I'm sure that will come, and that will just, be improving all the time, I think, from now on. But I think
for me that the golden standard of where we need to get to with these smart, I don't want to say because I've got a room full of smart devices that will respond if I say their name. But there used to be a TV program that the BBC made in the 80s, I'm going to say, called Star Cops. And there was a guy in that, and he had a little box. He called it Box. And it was like an AI, and he could have a conversation with it. He could say, book me the tickets at the cinema, and he could ask it questions, a bit like we would do with our smart home assistants. But it would have that conversational thread. It would carry on conversations and remind him, rather than just being quiet and only knowing, 1 or 2 levels deep.
Exactly, that's it. They only go 2 levels deep really at the moment, don't they? So you can say, play this music, and then or play this music on my hi-fi, and then you can say play the radio, and then it say, do you want to let it play on hi-fi? And you can say yes. That's the entire most deep conversation I've ever had with a smart speaker. I've never had anything more than that. And I'll do a try occasionally, because when it does happen, nobody will tell us. It'll just suddenly start working better, won't it? And you'll find that you can do these things. Because people at Google or Amazon have put a lot of effort into this stuff.
Yeah, I mean, one of the most popular videos on my channel is a build your own AI video. And what I've done with that is I simply used the Google speech service. So I have a microphone, it's all in Python, and I have the speech recognition, which is like a wrapper library, which does all the clever stuff in the background. You can do it on device, but I've just connected it to Google because it's like the best quality speech recognition, doesn't need any training. And then there's some pretty simple skeleton code, depending on what you say and what it brings back as the speech string, you can make it do something. So I've got it to do tell jokes or bad jokes. What else does it do? It can get the weather for where you are currently. It can have a list that you can add things to or take things away from. And I've just built up a few skills like that. And it's surprising how advanced that seems to be with just quite straightforward code in Python. I think it's that speech engine that really makes that work.
Not even trying to be particularly sort of smart about it, just kind of looking for patterns. And I think, that's a good sort of interim approach, isn't it? Because it does rely, if you plonked somebody in who didn't know what it was capable of, then it wouldn't work so well, would it? Because you know what it can do, and you know how to talk to it. So it's kind of, you've got a common frame of reference, haven't you, for making it do what you want to do. So that's what you want most of the time.
And for me, you talked about self-driving cars. I think the auto industry has got a long way to go to improve the software in cars, because at the moment it's like the first generation of mobile phones where they had software, but it wasn't very good, and every single phone seemed to be unique in how it worked, the menu structure, and And I think with cars, the entertainment system or the menu that you have on the screen, because they all tend to have a screen now, don't they? The sort of center console. And it's very hit and miss. So I've got a few different cars, and they all have very different software that works in very different ways. And I think I'd like to see like a common operating system, across all of them. So you could have your Linux or your Mac or your Windows type thing, but specific to cars. And there's a lot of rich data that you could have there. That's locked away in that car. You can't access, your mileage or where you've been on your car unless you've had an app outside of that ecosystem, like just a Google Map recording where you've been. But there's there's probably so much more rich data that you could get from that if only you could
You'd
unlock
need a
it.
very carefully designed API for that kind of thing, wouldn't you?
Yes.
It's kind of once you step into the realm of the safety critical stuff, you
Yeah.
can see manufacturers are not going to particularly want to be able to
Yeah.
either expose data that would implicate them in some way, or
That's
actually
interesting.
allow you to do things like turn your car off while you're driving or anything
Yeah.
like that. Just because you fancy linking up an Arduino to your
That's
car,
right.
there's a lot of recipe for disaster there, isn't there? But
Yeah.
I absolutely with you. It would be lovely. Going back to
Yeah.
my washing machine thing, if these things
Yeah.
just right, look, just let them talk MQTT. Life would be wonderful. We could have all sorts of fun for making little projects, and there'd be a huge ecosystem of
Yeah.
people making add-ons for these things and displays and what
Yeah.
have you. You know, it'd be
That's it.
good.
Something as simple as
Yeah,
like, your car's finished charging or do you want it to start charging? So I have
yeah.
a Renault Zoe electric car, and
Oh yeah.
there's an API that they don't tell you about but you can access, and it's just a very simple like a token to send to it to authenticate, and you can grab all the
Ah,
data from it. You can see how much mileage you've got, how charged it is, whether you want to turn on the air conditioning or not. You can do all that through an API. I quite like the fact that that's there, but it should be a bit more open. In my opinion,
yeah.
there's a
So
big
basically, this
opportunity.
is an unofficial API that somebody else has worked out the details of,
Correct.
and people are using it.
Yeah.
So yeah, it's. But that, I mean, that's great. I mean, I've got a plug-in hybrid. We weren't quite ready to make the leap into
Yeah.
pure electric, but I think probably next time we will. In fact, I know next time we will.
Yeah.
But one of the things I wanted to make myself was, because we have solar panels on the roof, was to make a diverter so that when we're generating
Yeah.
excess solar, we put it into the car so that,
Yeah.
free fuel, why not?
Absolutely. I definitely see that
Yeah,
as being a future direction for almost every house. You would have, because even if you've not got, I mean, the UK doesn't have a lot of sunshine, but we do have, it's not pitch black. We do have some passive sunshine. So if you've got a
yeah, yeah,
south facing roof, you can collect as much as you like. And then, yeah, store it in like a power wall, that kind of thing. Some 18650 batteries in some kind of safe configuration. You can just save it to that and then use it when you need to. Yeah,
yeah, yeah.
I could definitely see
I
that.
think, there's some interesting sort of uh, open source projects, aren't there, for making your
Yeah.
own Powerwall type
Yeah.
thing, that I think I've been quite tempted to have a go at that kind of thing.
Yeah.
But it's one of those things, even that if you want to sort of give yourself a decent amount of storage,
Yeah.
there is no escaping that it's going to cost you thousands. Is the
Yeah.
is the
Yeah.
problem, is the snag with it.
Yeah.
And that maker projects are fine, and I usually have a budget, but it's not usually thousands.
Exactly.
So it's never thousands. Let's be honest.
Yeah. Yeah. I have
So
a friend
it's
who he buys old laptop batteries off eBay, and they usually have more than 80% left in them when he
oh
gets them,
really?
because it might be
Okay,
that
yeah,
the screen's broken or something, but the battery pack in it, they're usually 18650s, and you can usually get a pair of them and balance them and so on. So yeah, he's got quite a few. He takes it camping with him, so he's got a bit of power for
okay,
TV and his electric shower and stuff like that. Yeah.
yeah, 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 good.
Yeah, so yeah, I think that's one of the areas I thought would be good for improvement, sort of the auto industry, and even just like the home. I mean, we have quite a few different platforms for home automation, but I still don't think I think we're still missing a trick with that. And I believe Apple and Google and who's the other one? They're all kind of getting together and agreeing a standard protocol for talking to all the
Oh,
different
that's good.
devices. So it really will open out when they do that. Yeah.
Yeah, yeah. I use Node-RED
Yep.
and MQTT
Yep.
on a Raspberry Pi,
Yep.
and I talk to Sonoff light switches. So you got flashed with a
Yep.
special firmware called Tasmoto, I think, or Tasmoto.
Yep.
Tasmoto.
I have quite a
Yeah,
few of them.
you done that. Yeah, no, and it's okay. It's all right. But I'm fairly conscious that if that Raspberry Pi dies, then going to be a serious
Yeah.
amount of pain. We're not going to be able to do very much at all.
Yeah.
Yeah, don't trust those relays at full load.
No.
Absolutely not.
Nope.
Uh, lights, just switch lights. I had some on heaters for we got
Yeah.
our workshop for turning them on a timer, and
Yeah.
they've all one by one fused,
Yeah.
switching at 13 amps or 10 amps even, I think
Yeah.
probably. But yeah, don't believe what it says on the writing on the thing. They don't do that, but
Yeah.
they're okay for lights and things.
Because I believe
Yeah.
that that's a bit of a design flaw in that they've got this solder track, and you're really just relying on the fact that that can carry the current. You know, is it 10 amps this is supposed to be able to carry? So I've seen a lot of projects where they go, there's a wire that's, you know, the correct.
Bridges it,
Yeah.
yeah, better way of doing it.
Yeah.
They're also the relays are cheap relays.
Yeah.
They can't cope with the current they say they can cope with.
Yeah.
I mean, to be honest, that looks like a label that whoever made that has stuck over the top of what it originally said on the relay.
But the great thing with these is that they are an ESP8266 chip underneath.
Yeah,
I think it's
yeah.
there, and so it's got Wi-Fi. You can program it with the Arduino IDE. I've done that. You can even load with Thonny MicroPython onto these. So
Okay,
I've done that as a project quite recently to
yeah.
get a light bulb
It's one
working.
of those things with your homemade projects. Is it's a lot of them don't always last that long.
Yeah.
Either you get bored with them and then they break and then you forgot how they work and then you've got to try and either figure it out and you think, no, I'll just make a new one in a different way because I've learned something else that I want to
Yeah.
try or something.
Yeah.
It's like I've got one really, really long-lived project which always astonishes me when it keeps working, which is from a book I did probably like sort of 10 or 12 years ago or something, one of my first books. And it's sort of an RFID garage lock for the garage door, just for the side garage door.
Yeah.
And we since lost the keys to the garage door because we had the builders in and they threw away a load of old keys that was because it was attached to the old indoor door or something. I don't know. Anyway, we haven't got any way of getting into this room now apart from using this RFID project that I did 12 years ago. And every time I go to the garage with my RFID key, I think at some point I'm just not going to be able to get into the garage anymore. We just had to move. But,
So talking about books, you have a new book out, I believe, a Raspberry Pi Pico book.
yes, thank you for mentioning it. Yeah. Yes. Let me hold it up to the screen. Can you see that?
Yes.
Okay.
Programming the
Yeah.
Pico.
So this is it's a departure from me because we're doing it as a self-publish thing. Well, actually via our company MonkMakes, and we're sort of trying to we'll probably might do a few more books on that. So we sort of paid for proper editorial support for it and layout and everything. So it has a sort of professional quality,
Yeah.
but we're actually publishing it directly on Amazon. But we'll also sell it as a product through things. So it focuses on it's a Python. Basically Python on the Pico. There is one chapter that talks a little bit about using the Arduino IDE and also using CircuitPython, which is an alternative flavor of Python that you can use with the Pico. So I really enjoyed that. As I say, I'm quite a big fan of the Pico. I think it's a great little board. From point of view, its natural home for me is in a piece of breadboard. I noticed you had yours in a breadboard, didn't you? And I think most people's Picos will permanently live in breadboard. Hence we get because it's the easy way to connect it up. You can just then plug in components around it, and then you can connect things together with jumper wires, and it's just a really nice little learning platform. So we actually have the book actually makes use of quite a lot of things in the Pico. We have an electronic starter kit for Pico product, which is a breadboard-based product. It uses our custom breadboard that's got the labels on for all the Pico pins, and then has some through-hole components, some sort of LEDs, a temperature sensor, and various other things that you can then plug in onto the breadboard and then make a few different projects with it. So it's I enjoyed writing that. It's quite fun. It's always that's the nice thing about writing. You sort of have to sort of get to the bottom of a new technology and then how it all works, and it'd be able to explain it to somebody else, which is always a good test of whether you actually understand it or not.
Absolutely, yes. Yeah, I think that's one of the tests, isn't it? If you fully understand something or not, if you can teach somebody else that thing.
Yeah, I think there's a Feynman quote originally, isn't there? Something like you don't really understand something unless you can explain it to a 12-year-old.
Correct. That's it. Yeah, so how long does it take you to write a book typically then? I mean, I guess it depends on how big the book is, but...
Yeah, and how much else is going on, really. When I was just writing, I would generally have a couple of books on the go at the same time. So if I got a bit fed up with one of them, I could switch over and do some work on the other one.
Yeah.
And I would generally, at some points I was doing sort of 6 books a year or something like that, really.
Wow.
Again, coming from a software background, I did spend quite a lot of time in agile software development teams, and a good way I actually find doing a sort of I create myself a spreadsheet and I put in estimated effort for each chapter and how many pages I think there's going to be in the chapter. And then the spreadsheet basically tells me how many pages a day I've got to write in order to meet the book deadline. And so if it says 2 pages a day, that's it. I'm laughing. That's fine. That's no problem. And it gets up to 8 pages a day. That's it. Time to renegotiate the deadline because that's not going to happen. But it does keep you on track so that you can then just treat it. So I treat it like a software project. Which is it does mean that you can generally hit deadlines, or at least know well ahead of time that you're not going to hit a deadline. Which is, if you're writing for a publisher, they need that because things go into catalogs and the sales force get told about them, and they really don't like it when you start changing the deadline.
Because I found one of the challenges with like creating robots, if I try and create one in a week, for example, if I hit an issue with the software or something's not quite working the way that it's supposed to do, or I've not quite understood something and it works exactly the way it does, I just haven't understood that yet. It can just take a bit of more time than I expect to figure that out. However, having gone through that, I then know the exact kind of pain points that other people go through, and that's a real value add, isn't it?
I would always say that the best time to write a book about something or explain about something is just after you've learned how to do it. Because you can remember the things that tripped you up. You can remember the things that that are likely to trip other people up, and it's a good time to do it. And also, everything's kind of fresh in your mind. You sort of know the things you didn't know, if that makes sense.
Yes, absolutely. Yeah, I mean, I always say that when I'm a contractor, so I'll work for different organisations as a project manager, and I always think the first 2 weeks you see the company as it is, and you can make some really good observations. After that time, you've probably gone native, and you're not aware of what you knew at that point. So it's really good to capture it at the moment, I think. So that's one of the reasons I started this channel, actually. It was to kind of document, a bit like you said about your book with the Evil Genius one, kind of to document my own journey as I learn more things about robots. And so I could go back and go, how did I do that? Oh, I did that video on it. I can now look and see what I understood about that.
Keeping a lab book, keeping a workbook is a really good idea, and just writing down everything you try, particularly when you're sort of debugging something, or you've got the first version of a board, and one of the things I quite often want to do is do a proper sort of electrical test on it, particularly for our micro products. What happens if they plug it in the wrong way around? I don't, will this be protected? If they do something daft with the wiring, because you don't want a lot of support problems with people just sort of accidentally destroying their boards. So if you can head it off fairly easily, which generally you can. But I like, as a sort of top tip for a sort of a notebook, look for something with squared paper. I like quite a big sort of A4 size, but with squared paper. And it's actually quite hard to find them. For some reason, that seems to be, we go to Spain fairly regularly, and that seems to be, if you go in the supermarkets there and look for a notebook, you'll generally find one of them, a squared notebook, just as easily as you will find a lined notebook. Whereas if you go into a supermarket here, you will only find lined notebooks. You won't find anything with squares in it. And so I'm not quite sure where you buy them, but I've got a stock of them because I always buy a few when I see the opportunity.
So I'm just scrabbling to find one of my notebooks. So I buy the ones with dotted paper. Because I find I can.
That's a nice idea.
So it's not quite as distracting as the squares, but you can use them as squares. So I was designing some faces on that particular one, and so I have like a lab book of things. I have the same type for work as well. These are, I think that's a Leuchtturm. Is that how you pronounce it? It's like a posh notebook, really. Leuchtturm, sorry, it's like a German name. Can I get that to focus on there?
So I don't like, if you're drawing circuit schematics and things like that, you either want faint squares or you want nothing at all. So that's the other thing I've used, is just a notebook with no lines or anything in it at all, because just a load of horizontal lines just makes it, difficult to follow.
Yeah.
And I know how to write in a straight line anyway, well, more or less. So I don't need lines. I'm not 12.
So I love these sort of A5 size books. These are my
Okay.
go-to, either Moleskine or
Yeah.
that Electrum or whatever it's called.
Yeah.
Yeah, interesting. Interesting. Most creators have that as well. So all the other people I've sort of spoke to and interviewed, they have their
Yeah.
own notebook as well. So it's interesting,
Yeah.
even in this age of digital
And a
note
nice
taking.
soft propelling pencil, a really good soft
Yes,
propelling pencil.
yeah,
I can't remember what it is. There's a Japanese make that every time you press the nib down,
yeah,
there's a little gearing thing in it that rotates the nib slightly.
yeah,
And it does it like 20 revolutions or something. So it does actually mean that you're never writing with the sharp bit of the nib or anything.
yeah,
It's a very geeky thing, but I do
yeah.
like
I like that.
I love a good propelling pencil, me.
Yeah. That's it. You kind of get these creature comforts. Like, I mean, these are not cheap. They're about £17 each, I think, as a
Oh, wow.
notebook. But
Yeah, and I'm
the
far
quality
too
of the
mean to do
paper on
that.
it, yeah, it's got a
Yeah.
real. You can write with a Sharpie and it doesn't bleed through.
Oh,
But
right.
it's
Yeah.
they're really good quality, but a bit expensive. But yeah, I don't go
Yeah.
through too many of them. But I do prefer working on them. I just find you can really zone out everything else and just focus on the thing that you're trying to create. So
Yeah, that's very true. Yeah.
yeah. Excellent. So I think we're pretty much done. Actually, I think we've.
Okay.
How long have we been going there? An hour and 25 minutes. That's flown by.
Well, that's been very nice. Very
Yeah.
interesting.
So thank you very much for your time. Really appreciate that, Simon, and all the best with the new book. I'll certainly be getting a copy myself, and I'll be also checking out MonkMakes and looking at some of the other kits you've got on there as well, because they're always good to have in the background, particularly things like the pin numbers on the breadboard. I'll be seeking that one out, I think, as well for myself, because that's always.
Right.
Yeah,
I'll send you one, Kevin.
That's very kind. I've got posters on my wall of all the different boards that I use, because the
Yeah.
number of times where I need to refer back to the pin numbers and stuff, I thought I might as well just print them out and have them as a a nice big poster. So
Yeah, yeah.
something
no,
people can
great idea.
download from
Yeah.
my Buy Me a Coffee website as well. I have a support
good.
side website there. So yes, anything else you'd like to
Brilliant.
say to the world while you have the floor?
Oh, no, I don't think so, really. It's just very nice talking to you.
Yeah.
And yeah, we'll have to do it again some other time. That'd be great.
Absolutely. Yes. Thank you very much, Simon. And
All right then, Kevin.
I shall see you later.
All right,
Thanks.
all the best.
Bye for now.
Bye.
Bye.